Hello everyone. In this video, I will show you how to create a grouped frequency distribution and more, how to display the information based on that frequency distribution. I'll be using this example. 20 randomly selected students were asked to estimate the number of hours that they had spent studying in the past week in and out of class. The responses are recorded below. So make sure you take the time to read the information, especially with statistic problems. You want to make sure you understand everything before attempting to complete the problem. So right here, we're using this example and this data, which is based on the number of hours students studied for this class. So what we have right here is numerical data, quantitative, right? And if you look at these numbers, you'll make sense of it by saying, okay, this is an answer a student gave, like 15 hours, 58 hours, 37 hours, and so on, okay? And we have only 20 students for practical reasons. In real life, studies are done on 20,000 values, 200,000 values, 2 million values, not on 20 values. But for practical reasons, in this class, we will be using this. So the first thing you need to know when it comes to creating distributions, there are some guidelines and there is a step-by-step process that we need to follow. So I'll write down the guidelines for choosing the number of classes. So when you are asked to create a frequency distribution, usually you are given a number of classes. They're put blank for now. We try to understand how to figure out with that number and what classes are. We'll talk about that a little bit later. The guidelines for figuring out this first number are the following. If they don't give you the number of classes, like in this case, you should use somewhere between 5 and 15 classes. These classes should be mutually exclusive. These should be continuous, all-inclusive, and of equal width. I told you at the beginning that this is a tough course because it uses terms that you never heard before. So it's actually the language of statistics that makes this course tough. For example, right here, we are using this word classes. We are using mutually exclusive. Mutually exclusive means they do not overlap. The classes do not overlap, meaning one value from here can be put in one class or another, not in both classes. So basically, if I start going through all of this to explain what these are, I'll just do that really fast. Classes are actually the intervals in which we will put this data. So we have to create a certain range where the values will be placed, should not overlap. Those should be continuous. Those should be inclusive. All data should have a place in those classes, and those should have equal width. We'll talk more about the width later. For now, for this problem, I'll be using 5 classes. Now, how do I create a frequency distribution, and why do I need to group the frequency distribution? Because I said at the beginning, this is an example of group frequency distribution. So first of all, let's see, why do I need to do all of that and how will I do it? I look at this data and I see that I have a large range. So the largest number is 58, the smallest number is 15. And because I have a large range and many data values, I will need to group or create those intervals, which we call classes. How do we do that? Well, there are a couple of steps. So I'll just write down the steps for creating a grouped frequency distribution. 1, find the range. We just found that. 2, make sure you know how many classes. We just decided we will be using these 5 classes. 3, find the class width. So here we go. Class width, this is a very important number. The way we will find this one is actually using the numbers from the previous 2 steps. Take the range and divide it by the number of classes. And then we will start filling in the table or the frequency distribution in a very specific way. First, find what we call the lower class limit of the first class. Then continue with finding the lower class limits of the next classes, and only at the end find the upper class limits of all classes. And this is really important, so make sure you keep that in mind. I'll explain why as we do this problem. So here we go. I will go step by step through this process and create the table. So for the first 3 steps, I don't really need to create any table. We found the range, which is 43 right here. We know how many classes. It was not given in the problem. We decided to use 5 classes. At this step, we have 43 divided by 5. And what's important to know about this number, it is a decimal. We will not be using a decimal. We will round up. Rounding up means round to the next integer. So this is a very important rule. And I would say this is a statistical rule. And even though you don't really see any difference between rounding, the mathematical rounding that you are used to with, and rounding to the next integer, I want to give you an example where you will see a difference. Not in this case, though. 8.9 will be rounded anyway to 9. But if you have 8.2, if somehow you get to this value, you will still round to 9. Even if you have just 8, an integer, you will have to do statistical rounding and it will be 9. Now, if you want to try and forget about rounding and complete the process, you will see that by the end, you will not have enough classes to put all the data in. So your classes will not be inclusive. You'll be left with some large values and you will not know where to put it if you do not follow this rule. So make sure you follow this rule. And now that we have the class width, which is a very important number, we will start the process. And they tell us how to start this process. Step 4, it says, find the lower class limit of the first class. What is that, the lower class limit? Well, it's where we start. So I will have the frequency distribution table here first. And I know that I have my classes right here. And these are actually called class limit. Now, what you've seen on the previous video on those examples for group frequency distribution, you've seen a range of values for the first class. So this is where we have the first class and then the second class and so on. Each one of those intervals starts somewhere and ends somewhere else. So that's what you've seen, an interval of values. And I'm referring to the first video in this chapter. This is what we call the lower limit. And this is what is called the upper limit. In this instruction, it says take care of the lower limits first for each classes, and only at the end, take care of the upper limit. So where should I start? Step 4 says lower limit class of the first class. Well, what makes sense to be put first in there? Well, I inspect my data, and I do realize that the lowest value in this data is actually 15. So this should start at 15. Where it ends, I don't really care right now. What I will do, though, is I will complete the lower class limit of the next classes. How? By adding the width. Width has power. Right here, it's a very important number. So from 15, I will add 9 and I'll get to the second class and lower limit. And then again, I'll add 9, keep adding 9. And that's how I will get my limits. So let me grab the blue color and I'll have 24, then 33, then 42. And the last class will be 51. I have 1, 2, 3, 4, 5 classes. Now the upper limit. In order to identify the upper limit of the class, I'll go back here and I see that these classes should be continuous, not mutually exclusive, right? So I want to make sure that this will not overlap. So if my second class starts at 24, this first class will end at 23. I hope it makes sense. So if this one starts at 24, that one ends at 23. And then again, I look at the next class. This one begins or starts at 33. So this one will end at 32 and so on. Now, how do I know what to put for the upper class limit? Well, as I said before, keep adding the 9, 59. This is how you determine the class limits. These are actually the intervals. This is the first class, second, third, fourth, and fifth. And all we have to do is count how many values we have in each class. But if we want to do this by hand, this is a long process because, well, I have to go through each one of these 20 values. Now, it's not impossible. 20 values is not a lot. But think of 20,000 values. You don't want to do this by hand. We have technology that will help us do this. So anyway, just to give you a taste of how it looks like when you do it by hand, you can just tally. Just look at 15 and say, okay, 15. 15 is between 15 and 23, so you tally. 58 is in my last class. 37 is here somewhere in my third class. 42, it's right here. 20 it's right here, and you keep doing that. Now, I will not do that. If you want to continue, that's fine. But what I want to do, I want to use technology to help us figure out the frequency for this frequency distribution. Okay, make sure you grab your calculator, and I'll show you how to use the calculator. In this class, we'll be using these two keys. So I clicked on stats. When you click on stats, this is what you see, and you are on edit, and we will be editing. So hit enter, and you should see some list. Now your list will be empty, or you'll have some values. Now, if you have some values, and I will enter some values in my second list, I'll enter this value just to show you how to get rid of those. Go to the top of the list. You see this is highlighted, and hit clear. Do not hit delete. If you hit delete, you will delete the entire list. You don't want to do that. Clear. This is what happens here. This is clear, and then hit enter. Now, I already entered my values in the list 1. I will start entering the values in this list just for a couple of numbers, just to explain how you should do it. But just put it in list 1 or any other list you want, but usually in list 1. The values are right there on the screen. The first one is 15. You hit 15, and then you hit enter. 58, enter. 37, enter, and so on. You will populate the list with values. Now, hopefully you are doing that in list 1. I already have it in list 1. If you do it in list 2, that's fine. Just stop the video, have the values in, and then come back. What I will do next is I will clear this list. I don't need this list. I have my values in list 1. I'll go back to stat. And you see on this screen, you have some other functions that the calculator does. We are interested now in sort ascending, which is the second one. So use arrows to get to sort ascending and hit enter. And now it will wait for you to tell which list. Now, if you have your values in list 1, you'll have to say list 1. If you have it in list 2, you'll have to say list 2, and so on. Where are the lists? The lists are the second options for the digits. Look at this. Mine is blue. Yours may be a different color, but blue will activate list 1 if I hit 1. If I hit 2, it will be list 2, and so on. I will do list 1, close the parentheses, and I hit enter. So make sure you hit enter, because then you will have the confirmation is done. Hit on stats again, go to your list and look at your list. Is this in order? Well, go to list 1 and inspect the bit using the arrow, and you will see these are in order. Okay, now how do I use this? Well, I look at my classes from 15 to 23. How many values do I have? Well, look at this. The first 2. Now from 24 in the second class, right? Starting with 24 up to 32, you have 1, 2, 3, 4 values. Because the next one is 36, this will be on the third class. Okay? So this is how you can use the calculator to help you organize data. And now if you count using the calculator and you're doing that correctly, you should have 2 values in the first class, 4 in the second, 4, 4, and 6. And we know already that the summation of this frequency column should be 20. And this is what is called the frequency distribution for grouped data. However, we will expand a little bit this one because we need to display all of this information in graphs. And for that reason, we need the following columns. So the next column I want to talk about is called cumulative frequency. Now, cumulative means accumulate. So the process of creating this column goes through accumulating values from the frequency column. So whenever you have lots of columns, just focus on a few or just one. This refers to accumulating from the frequency column. How do we do that? Well, as simple as start with what is in the first class, and then on top of it, keep adding what's in the next classes. So I will put a 4 on top of the 2, and I will get the 6. Then I have 6 for my second class. I'll move on to the third class by adding on top of the 6, the 4, and that will give me the 10 on the third class. Now I have 10 on the third class, and coming up, it's the 4 from the next class, which will accumulate to 14. And continuing the process, I end up with 20. There should be no surprise that right here I have 20, and right here, the summation of all of this is 20. I should end up with 20 because I am accumulating. So I hope this makes sense. Another column, and you've actually already completed this column in the first video. It's called relative frequency. Relative frequency, again, we are looking at the frequency column. It's about frequency. So look at the frequency column. And what we simply do is we form a ratio between what's in the first class and the total number. So it's 2 out of 20, which is 0.10, 4 out of 20, which is 0.20. The next class will also be 0.20 because it's still 4, and 6 out of 20 is 0.30. You don't really need to show the work, you just need to state the percentages or the decimals. And this is the relative frequency column. I'll continue with 2 more columns that are needed in order to move on and graph all of this information. So I'm expanding this frequency distribution. Don't worry, when you have to create a frequency distribution, you only need 2 columns. If they want more columns, they will tell you which columns you should use. So right now I have another column which is called a midpoint. Let's just think back of what a midpoint is. A midpoint of any interval, and I'll write down the definition right here, is the lowest value in that interval plus the highest value divided by 2. So right now, we are looking for the midpoint of each class, meaning we are looking at the classes. Just ignore these other columns. We're not interested in that. We are looking at the first class and then second class and so on to find the midpoint. For the first class, these are the lowest and the highest values. This is 38 divided by 2, which is 19. So here is my first midpoint. Now we can continue the same process for the second class and so on. However, I want to use the power of the class width. I can use the class width for everything that's related to this column. So instead of doing the work using the formula, I simply add 9. In the second class, I have 28, then I have 37, and then I have 46, and my last point is 55. Now the last column I want to add here, and I need to add that, is called the class boundaries. And I am thinking to add this column right here because it's related to the class limit. So this time I'll just try to expand this way. I'll squeeze this in here. These are called class boundaries. Now for the class boundaries, this is what happens. As I look at all my classes, I see that there are gaps in between 23 and 24, 32 and 33, basically between the end of one class and beginning of the other class. Let's try to visualize this here a bit. This is, and I'm just looking at the first class and the second class, but the process repeats through all of the classes. Here is the gap. In the guidelines for creating classes, the classes should be continuous. There should be no gaps in between that. So what do? Well, I'll take care of the gap this way. I'll simply look in the middle of the gap, and the middle of the gap will be the middle between these 2 numbers. So the middle number, the midpoint, is actually 23.5. So I will simply extend the first class by adding 0.5 to the upper class limit and extend the next class by subtracting 0.5 to the lower class limit. So basically, to come up with these class boundaries, I'll just simply add, in this case, it's 0.5 to these upper class limits and subtract 0.5 to the lower class limits. But it's only in this case. Sometimes you have to add 0.05 or 0.005 and subtract that number from the class limit. Depends how the data looks like. I hope that makes sense. So my values right here will be 23.5 for the upper classes, 32.5, 41.5, 50.5, and 59.5. For the lower classes, it will be 14.5, 23.5, 32.5, 41.5, and 50.5. This is how I created the class boundaries. So I hope this makes sense. It is a lot of work. I expect you to do this just for practice by hand. However, from now on, we'll not really be doing this by hand. We have calculators, we have Excel, we have some other software, but there is value in trying to do this set of problems by hand. So make sure you practice. And I will continue with displaying the information in graphs. So here we go. I may need to get rid of some of this. We will be talking about displaying information in as a histogram, frequency polygon, and ogive. Here we go. Frequency polygon, ogive, and of course the histograms are the three most commonly known graphs in business. So how do we create such a graph? Well, such a graph is not created by hand anymore, but you need to know a few things about this. We'll try to create this by hand, okay? But first of all, we want to talk a little bit about what these are. Keep in mind, we are displaying quantitative data. These are graphs for quantitative data, numerical data, okay, quantitative data. A histogram is a bar graph for this type of data. It has some specifics. On the x-axis, there should be the class boundaries, and the frequency should be displayed on the y-axis. Of course, there should be a title, okay? Now, if you see some graphs or you do some graphs, instead of the class boundaries, you use the midpoints, it's still considered a correct graph, okay? But most of the time, class boundaries should appear on the x-axis. So in order to graph this one, I will need to look at the class boundaries. That's why we have this column right here and the frequency, this column right here. Now, if instead of the frequency, someone uses the relative frequency, this will be called a relative frequency histogram. So I will try to quickly do this by hand. This is the histogram, and I will do it right here following the instruction. This is where the data is. I will display right here time in hours. I will display the boundaries. So 14.5, 23.5, and so on. And I'm using estimation, of course. And right here, I'll be displaying the frequency. And look at the frequency numbers up to 6. So I can just simply use 1, 2, 3, 4, 5, 6. And I will simply raise bars for each class for the corresponding frequency. First class, it was 2. The next classes to be 4. Okay. And I actually have this graph as an example. In the next video, I'll show you the graph done by Excel. This is how it looks like. Whenever you have a graph, make sure you give it a title. This is time used for study. Okay? It's really important to have the title and the data. Make sure right here you have the class boundaries. And this is an example of how you create a histogram. Okay? This is a histogram. As you can see, it's a bar graph, no gaps. Now, frequency polygon. And I need all of this extended table in here. That's why I will do the graphs on this side. Because for the frequency polygon, we have a couple of things to remember. This is a line graph. On the x-axis, we have to put the midpoints. So right here, we do not have a choice, just the midpoints. On the y-axis, we use the frequency. And also, this bar should be anchored because a polygon is a closed shape. So this is what I'm going to do. I'll put the midpoints right here. The title is the same. Okay. I'll try to erase these bars. So the midpoints were, and I'm looking at the midpoints right here, 19, 28, 37, 46, and 55. So these are the midpoints. I'm simply putting a dot for the corresponding frequency. So 19, we have 2, and then we have 4 for the next classes, and 6 for the last class. I will connect these ones, and I'm not done because I need to make sure I will anchor it back to the x-axis. So I will need to extend this to the x-axis, but where on the x-axis? Now keep in mind, these are all scaled by using the width. So we need to be consistent. So the next point right here using the width will be 10, 19 minus 9. That's how I anchor it. The next point right here should be 64, class 9, right? So this is an important feature of a frequency polygon. So this is a frequency polygon, closed shape. And the last graph for quantitative data that is used in business is ogive. So let's talk a little bit about ogive. I will make room here, and I'll see how I will actually change some of this to create the ogive. It's an interesting name. It's actually a cumulative frequency graph. What does that mean? Well, instead of using frequency, it will use the cumulative frequency on the y-axis. On the x-axis, we have the upper class boundaries. On the y-axis, we have the cumulative frequency. And this graph should be also anchored, but only at the start. So here we go. We will follow the instructions and construct an ogive. So data right here is time in hours. And on this axis, I should put the upper class boundaries. Let's look for the upper class boundaries. These are the upper class boundaries. And then this is the cumulative frequency. This is all we need from this table. So here we go. Upper class boundary starts with 23.5, and then 32.5, 41.5, 50.5, and 59.5. Now, cumulative frequency goes up to 20. So I'll just count by twos, but just keep in mind right here, this is unique. It's a cumulative frequency. This is what's different about this graph. Okay, so I have 2, 4, 6, 8, 10. It's very busy. I should have used a larger scale for the y-axis. Anyway, here is 2 for the first class. For the next class, it's 6, you see. That's a 6. So I'll just go to 6. For the next class, it's a 10. And then we have a 14. And I'm estimating, of course. So it's a line graph with a cumulative frequency on the y-axis. It will go up. So it makes sense that we will not be anchored here, but only at the start. How do we anchor? Well, this is 9, right? Again, the magic number in this case, it's 9. So going back here and anchor it to 14.5, it will make sense. 23.5 minus 9, just to be consistent. So this is what we call an ogive. So these are the most common graphs in business. And keep in mind, these are used for quantitative data. In the next video, we'll show some graphs for qualitative data and some other types of organizing and displaying information.